This is Euclid Book 10, proposition number 86. Okay. To find the second apotome, let a rational straight line A be set out. There it is. And GC commensurable in length with A. Okay. So now we have this line here, and it's commensurable with this. Therefore, this one is rational. Okay? Let two square numbers, DE and EF, be set out. Okay? We're going to represent DE and EF, okay, right up here. And let the difference FD not be square. Okay, so this here is not a square. We don't know what it is, but it's not a square, so we're going to represent that with a rectangle. Now let it be contrived that as FD is to DE, as this is to this, so is the square on CG to the square on GB, as this is to this. This is by Euclid Book 10, proposition number 6, Porism. Therefore, the square on CG is commensurable with the square on GB. Okay? This is commensurable with this. These two are commensurable. That's by Euclid Book 10, proposition number 6. But the square on CG is rational. That's rational. Therefore, the square on GB is also rational. That's rational. Therefore, BG is rational. This line is rational. And since the square on GC has not to the square on GB, the ratio which a square number has to a square number, as this is to this, so it is not a square number has to a square number, CG is incommensurable in length with GB. Okay. This is incommensurable with this whole line. This is by Euclid Book 10, proposition number 9. And both are rational. Therefore, this line here and this line here, they're both rational lines, and they're only commensurable in square. Therefore, BC is an apotome. This is by Euclid Book 10, proposition number 73. I say next that it is also a second apotome. We'll let the square on H. We're going to take the H here, we're going to make it into a square, and there it is. Okay. Be that by which the square on BG is greater than the square on GC. Okay. This one's going to be bigger than this. Since then, the square on BG is to the square on GC, as this is to this, so is the number ED to the number DF. As this is to this, so is this is to this. Okay. Therefore, convertendo, as the square on BG is to the square on H, as this is to this, so is DE to EF. This is to this. Okay? So as this is to this, so as this is to that. This is by Euclid Book 5, proposition number 19, Porism. And each of the numbers DE and EF is square. Therefore, the square on BG has to the square on H. This is to this. The ratio which a square number has to a square number. Therefore, BG is commensurable in length with H. This is commensurable with that. That's by Euclid Book 10, proposition number 9. And the square on BG is greater than the square on GC by the square on H. This is bigger than this by this. Now, what do we mean by that? If you added the area of this and this together, if you added these two areas together, you'd get that. Therefore, the square on BG is greater than the square on GC by the square on a straight line commensurable with BG. Right? And CG, the annex, this is the annex here, is commensurable with the rational straight line set out. This is commensurable with that. Therefore, BG is the second apotome. This is by Euclid Book 10, third set of definitions, number 2. Therefore, the second apotome, BC, has been found. That's your second apotome. Okay. I will tell you more in a future video, so I want you to stay tuned.